Hello and welcome. I'm James Murphy from mCoding. In this video, we're going to be talking about how to make your Python code faster. I'm going to tell you about the one tool that I use that really helps me make my code faster when I think that it's just not performant enough. It's actually really surprisingly easy to find out what's making your code slow. This is one of the most common questions that I get. People come up to me and they ask, James, I know Python, I know the language, I know basic algorithms, and I wrote this thing. It's a great project, but it's just not fast enough. What did I do wrong, and how do I figure out how to make it faster? Instead of just telling you, let me show you how I would diagnose and fix a slow code problem with an example. So let me just go through the process on basically a little function here that I've written. What it does is it goes out, I have a list of the top 15 US websites, and it just goes out, grabs the HTML from all those websites and parses it and counts how many times it sees HTTP versus HTTPS in those websites. For this example, I know it looks kind of simple, but there's a bunch of things wrong, and this method is just going to show you, it's going to point directly to what the real problems are, not just what are the little things that could have been better, but don't have any actual noticeable performance impact. So to get started, looking at this, first thing, we're reading from disk. That can take a while. We have an accidentally quadratic thing happening here where I'm not appending to the list. I'm using plus. We have a GET request to a website. Then we do a bunch of text processing. We're using find all instead of a precompiled regular expression. And then we have a random sleep statement that someone forgot to delete somewhere. There's just tons of things that could be the source of why this code is slow. And just to start things off, let's see how slow this actually is. It took almost 12 seconds to go out to 15 websites and do this text processing. So let's just say that for my purposes, that's way too slow. If you've ever worked on a real project and tried to do this, oftentimes you find that you can spend hours and hours doing something that you think is going to make the code better that ends up having basically no impact on the performance at all. So that's why this technique that I'm about to show you is so valuable, because it will point directly to where in your code is causing the slowdown. So what is this tool that I keep talking about? Well, it's profiling. There's two things that I want to talk about with profiling. First, just using the basic profiling built-in tools, and then a special web-based, interactive way to view the data that you get from the profiler. So here's the basic setup of how you use the built-in Python profiler in CPython. Basically, you just do a with cprofile.profile as something, and then put inside the with block whatever it is that you want to profile. And there are a lot of different options in the profiler. You can do pretty advanced stuff like turning profiling on and off for certain function calls, things like that. But the most basic thing that you can do in profiling is, I would say about 95% of the time, all that I actually need. So we do our profiling, we call the thing that we think is too slow, and then after it's finished, then we get the stats from the profile. And it's important to do this step to sort those stats, because we don't want to just look at the thousands and thousands of function calls. We want to know which are the ones that took the most time. So here's how you say, sort those statistics by how much time each function call took. And then let's just go ahead and print them out. You can see that it keeps track of every function call, how long it took. So it, again, took about 12 seconds. And these stats are ordered by how much time that the thing took in total. The one that you really want to look out for is this total time spent in the function. That's this, tot time. As you can see, that the most time that we spent in total was in the read method of this ssl.ssl socket. And then behind that, you can see that we have this time.sleep, which we spent 2 seconds in. And then the next few of them are all these SSL things. You can see it's already pretty easy to just read off of this what the actual slowdown is caused by. But let me show you one more thing you can do to make it even easier. And that's to use one of my favorite tools, just pip install it. It's called SnakeViz. So let me show you how I would use SnakeViz. What you actually need to do is, instead of printing the stats, let's go ahead and dump the stats to a file. And then will give this file to SnakeViz. So I just finished running the code again, and so now all of these statistics should be saved in this file, needsprofiling.prof, and then look how easy it is to run SnakeViz and visualize those statistics. So I just say SnakeViz, and then I give it the name of the file, and I hit enter, and this actually automatically brings up my browser. Let me switch over to that view. There you see it. So just by visually inspecting this, I can already see that regular expression matching is not the problem, reading from disk is not the problem, text processing is not the problem. There are two clear problems that are in the code, which we can see both from the Icicle plot and from the statistics from before. And right away, you can see that there's 2 seconds spent sleeping. That's a big red flag. And the rest of this is all under get. So I immediately see that these get requests are what's really taking all the time. And if you've done any programming with, doing things over the network, you probably already knew just by looking at the function that that's what was the big slowdown. Let's make another version of the function and see how fast we can get it with just a little bit of directed effort. Now that we know what the real problem is, let's see how much better we can do just really focusing on those things that were actually the slowdowns. Okay, well, here's the random sleep that someone forgot to delete. Obviously, we can just delete that and that'll, take 2 seconds off the time. The next thing was the request.get. So here it is. Here's the real problem, and we're doing it in a loop. So how can we make that faster? I don't have anything bad to say about the requests library. It's basically one of the most well-written libraries in all of Python. It's extremely easy to use. The API is very intuitive. It teaches you all about the internet just by using the library. It's just a great library all around. But the one thing that's really getting in the way here is that requests is a synchronous library. So what that means is when I do a request.get URL, it goes out to the internet, it gets the URL, it gets the HTML from that page, and you can't do anything else while that's happening. But I will say there's a pretty up-and-coming HTTP library which is built to be asynchronous. So all I'm going to do is switch out requests for that other library and then see if that makes things better. So HTTPX is this library that I'm talking about. It's basically a drop-in replacement for requests if you need it, but it also supports an asynchronous style of doing the requests. And then I'll also need async IO in order to run a basic event loop. So let's see how we can modify our function in order to use the HTTPX library. The first thing that I need to do is just mark this as an async function. And then let's go ahead and kind of like rewrite this block. I'm only going to rewrite this. I don't think I need to rewrite any of the other stuff because they weren't what was really slowing the code down. So what this is going to do is create an asynchronous client. So this, you need a library that knows how to do this, and it will asynchronously go out and get all these URLs. And then what gather does is it just waits for all of them to finish in whatever order they do. It doesn't block any of them. But then I am going to block here. I'm going to wait until they're all done. And then after they're all done, then I'll go through and, instead of intertwining the get with the creation of the HTML list, I'll get rid of that. And there you have it. That's basically all I'm going to change. Okay, so let's go ahead and profile this version and see if it does any better. So, of course, now we have to change the name. And because this is now an async function, calling it like this doesn't actually run the function. We need to schedule it to be run. So we'll use async io.run, and this will actually run the coroutine. And then once it finishes, then it's all the same. Okay, here's the profile now. Immediately, you can already see that it only took 2.5 seconds. So way, way faster, huge speed up. All we did was do the web requests in an asynchronous manner. We're still just using one Python process and one thread. So this isn't parallel programming. This is asynchronous programming. Just one thread, one process, but a whole bunch of coroutines. All right, that's all I've got for this introductory video on profiling in Python and using SnakeViz to find out why your code is slow and how you can make it faster. I hope you found it useful. If you did find it useful, please don't forget to like the video. And if you especially like the video, please consider subscribing or maybe even becoming one of my patrons on Patreon. I want to give a special shout out to my patrons on Patreon. I really appreciate your support. Thanks for watching and see you next time.